we need 5 columns, we label the columns correctly, and we are done. Okay, throughout the trace, we only use the columns that have been labeled from the start. Once we have subroutines, that changes that particular part, because now we can dynamically allocate a column and deallocate a column. In other words, at a certain point of the program, I can say, oh, I need a new column to remember something. And then later on, I can say, oh, I don't need that column anymore. I will deallocate the column so it can be reused for something else later. Okay? Are we doing okay so far with the concept of, we do not use a fixed number of columns anymore at this point. On line 6, we have 2 things to do, and I will comment, like next to it. Okay, 2 things to do. Okay, and I'm just gonna write down here. The first thing we're going to do is to remember where we are. And then the second thing we want to do is to go to the subroutine. Okay? So that means I have to use a new column. The new column will be labeled return line number. In other words, when I'm done with sub 1, where am I supposed to go?
Line 7.
Line 7 is the correct answer. Okay? We don't want to say line 6, because if the return line number is line 6, then we have an infinite loop, because line 6 will try to invoke the same subroutine again, and it will remember to go back to line 6 again. So that's why it is important to remember, when you specify a return line number, you always want to specify a line that is logically following the invoke statement, which may or may not be exactly the next line, because if you have the invoke on the very last line of a conditional statement, then the line that you return to is going to be the statement after the conditional statement, not the end in. Okay, so we'll have examples to illustrate that later. Okay, so there are 2 things here, because the next thing we want to do is, what is the next line that we are executing?
7.
No. The next line is line 2. Line 2 is the first line inside the subroutine that has something to do. Okay, so let me just highlight these portions here, because these are all important. So we go to Format, Cells, and I'll just give it some color for the background so that we can highlight this part of the spreadsheet is important. Can everybody see what I have just done? 2 things. First thing I have to do before I go to line 2 is to allocate a new column, label it return line number so that I know what that column is used for. And then I remember, oh, by the way, when I'm done with sub 1, remind me that I have to go to line 7 to continue execution. That's the first thing that I have to do in a subroutine. The second thing I would do, once I remember where to go back to, now I can actually go out into the subroutine and start execution on the first line inside the subroutine that has something to do. The first line of a subroutine is nothing more than a label to indicate this is the beginning of a subroutine called sub1. So I don't start execution there. I start execution on line 2, which is actually a statement, an assignment statement that does something useful. Is that okay so far? Okay. What does line 2 do? Well, line 2 is something that we have done, again and again. All it's going to do is to add 1 to x. Okay, so x goes from 0 to 1, and then we go to line 3. Now, once again, why is line 3 executing here? Because it seems like line 3 is almost the same as the end if, the end while, the repeat type of lines, where it is only used as a marker to mark the beginning or the end of a construct. But in this case, because it is a subroutine, there are also specific things that we have to do at the end of a subroutine. And that's why end define sub is not just a label, it is also indicating that you have to do something special there. On line 3, I have to decide where I'm going back to, as well as deallocating the column that is no longer useful. The first thing I have to do is to remember, oh, okay, I'm at the end of a subroutine. I better, ask where I'm supposed to go to continue execution. In this case, I go back to line 7 to continue execution. So I put a 7 here as the next line to execute. But also at this point, I have to say that this line is no longer needed. When I use the X's, on a particular cell, it is saying that this column is now quote unquote deallocated. It is no longer in use. Are we okay, with the concept? Yep.
Why is it no longer in use?
Because I don't need it anymore. I have just utilized the value that I have stored in this column, so I know where to continue execution. As a result, I don't need this column anymore because I have just utilized, what it is here for. Yep.
So it stores the number in line 6, and then at line 3, it goes to that number.
It uses whatever I have in column C to indicate where to continue execution when I'm at the end of the subroutine. There was another hand. No? Okay. So are we doing okay so far with this trace? Let me just comment on here of the 2 things that we have to do. So once again, we got 2 things to do. One is to, the order is important here because I have to remember to specify in the right order. The first thing to do is to retrieve where to continue execution from a return line number column. And then the second thing we have to do is to deallocate that column. Deallocating a column means the column is now marked unused, so we can use it again. What does line 7 do?
Multiply x by 3.
Yep. So x is 1. 1 times 3 is 3. We store 3 back into x. X is now updated to 3. So let me just highlight the important part here. So this way we know that it is an important portion of the trace. So once we get back to line 7 is not special anymore. What about line 8?
Goes back to line 2.
Exactly the same thing. We have to do those 2 things, okay? We don't want to go back to line 2 until we have remembered how to continue execution when the subroutine is done. So what we need to do is to reallocate column C in this case. But column C was used already. How can I reuse that column?
Because you deallocated it.
Because I deallocated it. Exactly.
It's
Okay?
like building a brick wall.
It's like reusing something. It's basically, reusing something.
Recycle.
Yeah, kind of. Reusing. We're reusing the same column. But this time, what do I put as the return line number? Post. Very good. You guys are good. So we have to put a post here because, when we are done with the subroutine, there's nothing else to do. Okay, and therefore we use post to indicate that there's nothing else to do when the subroutine is done. And then what do we do? Once we have remembered where to continue execution, then what do we do when we invoke a subroutine? Well, we just go into the subroutine and execute whatever is stated in the subroutine definition. In this case, line 2 is the first line in the subroutine that does anything useful. What does it do, by the way? Line 2 is going to add 1 to x. X has a value of 3 at this point. 3 plus 1 is 4. And when we're done with line 2, we go to line 3. What do we do when we are at the end of a subroutine? There are 2 things that we have to do. We just stated here. We have to retrieve where to continue execution. Well, this is saying post. So I'm going to continue execution. The next line is going to be post. I know post is nothing to do, but we have to remember that's where we're going. And what is the second thing we have to do at the end of a subroutine? Deallocate it. Okay? So that's the trace of a program that uses a subroutine. Let me make sure I can save the file first. Just hold on a second. Let me create a new folder for this class today. 2010, 1019, cisp300. And this way we can save the file. I just call this sub1. Are there any questions at this point? This is something that we have not seen before. We have not, allocated a column dynamically before. Yep.
When you're allocating a column, is it like allocating memory and then deallocating the memory as the program runs?
When you're running this program inside a computer, it really translates to, certain locations of the computer are now in use. Whenever you allocate a column, you are basically marking and say these locations are now in use. Okay, that's good. Yep.
I didn't get it. Why did you use both?
Because
There's no more code to run.
Exactly. Because when we execute the invoke statement on line 8, we still have to remember where to go to continue execution. But in this case, there's nothing else after line 8. So to mark or to indicate there's nothing else to execute after line 8, we have to use post in column C, so that when I'm done with a subroutine, it remembers, oh, by the way, there's nothing else to follow. We just go to post. Because post is an indication that we are at the end of the execution of a program. Okay. Any other questions? Can you guys see how how column C is really useful in this case? Because every time right before we go into a subroutine to continue execution, column C in this case is being used as a breadcrumb. Okay. Just so that we can indicate, okay, when I'm done over here, where am I supposed to go to continue execution? And the one thing that you have to remember is the first time we invoke the subroutine sub1, the return line number was 7. The second time, the return line number is post. In other words, every time you invoke the subroutine, each time you have to think about where am I supposed to go back to when I'm done with the subroutine. Yep.
What's the difference between a subroutine and a function?
A function is a special kind of subroutine. But at this point, we don't talk about functions yet. We just talk about subroutines in general. Okay, that's a good question. Any questions about subroutines at this point? Are we convinced that we can invoke a subroutine from many different places in the same program? In other words, in this case, I can have a program that is much longer than this, and I can sprinkle invoke someone throughout this program. That should not be a problem. Yep.
What happens if you have a subroutine invoke another subroutine?
That's my next example. Very good. Okay, so you guys are definitely on the right track because you are just thinking ahead of me. Very good. So we'll answer that question next. Yep.
What's your feeling about go-to statements?
It's a taboo. It's almost like saying the F word in the class. we call it the G word in programming. Yep. So we never say the 4-letter G word in programming. Are you guys getting it? The go-to statement is a taboo. It doesn't mean that it does not have a meaning, just like the F word has a meaning. Okay? But to use a go-to in a program is very, very bad. It is not bad in the sense that your program will break. It is bad in the sense that your program will be difficult to debug later on. Okay? So in this class, I do not talk about the go-to statement, and I just tell you guys, do not use the go-to statements. There are usually alternatives, to using the go-to statements, unless you're using assembly language. When you're programming in assembly language, then the go-to or the jump statement is the only way to get around something. But this is not assembly language program. Sorry, go ahead. Yeah, exactly. However, in assembly language programming, we call it jump, so it's not a G word. It's a J word. It's not a G word. Okay? Are we ready to move